Trig, section 5.3, the sum and difference identities. First of all, let's introduce the sum and difference identities. The sine of A plus or minus B, the cosine of A plus or minus B, and the tangent of A plus or minus B. Now what these plus or minus means, you can have sine of A plus B, the sine of A minus B. But we put them together because their forms are so similar, the only thing that changes is the sign. So for the sine of A plus or minus B, the identity for that is the sine of the first, sine A, the cosine of the second, cosine B, plus or minus. So if it's a plus here for the A plus or minus B, then it's also a plus here. The sign's the same. But you've got to switch the angles. Now the way I remember it is cosine A and sine B. But I would count sine B cosine A. So it's sine A cosine B plus or minus sine B cosine A, or sine A cosine B plus or minus cosine A sine B. Switch the angles, but leave everything else could be the same then. The cosine plus or minus, well, it's the cosine of the first times the cosine of the second minus plus. That's important. If you put plus or minus, you'll lose a point, because when it's positive, here it's negative. When it's subtraction, here it's addition. And the sine of A times the sine of B. The tangent, because it is a fraction, is also a fraction. So it is the tangent of A plus or minus the tangent of B. Wow, wouldn't that be nice? It's not. Over 1 minus plus. Numerator plus minus, denominator minus plus, the tangent A times the tangent of B. So I will be giving you the left-hand side here. You will be giving me the right-hand side. And we're going to put that in a quiz for you. But you should be asking yourself, well, hold it. I don't see that. You better prove it to me. Well, we will. What we're going to do first, I guess, is get a new screen. If we have a circle, and in this circle, we'll put this in standard position. Now, let me change color so it's a little easier to see. Suppose we have angle A, say, is big. It doesn't really matter. This should work no matter what. So here's angle A. And angle B is maybe then smaller. So here's angle B. Now, where is angle A minus B? Well, that's here in between. This is angle A minus B, right? Because you go over A, degrees, radians, and you go back B. You subtract B from that, and you get what's between. Now you say, well, okay, that's cool. How is that going to help? Because we're going to look at it a different way also. Suppose we go B first and then subtract A second. Well, then this one between here is B minus A. But what about the degrees? If this were 60 degrees, what would this be? Well, you might say it's a negative 60, but we don't care if it's a negative 60 or a positive 60. It's going to still be the same angle, 60 degrees. With that in mind, we need to start talking about, because this is the unit circle, this point is the point 1, 0. And on the unit circle, all of these points, their coordinates are the cosine and the sine of the angle. So this is the cosine of b minus a, comma, sine of b minus a. And this is, because this is on the unit circle, this is angle B, so this is the cosine of B and the sine of B. And this is the angle A, so this is the point cosine A, comma, sine A. On the unit circle, because r is 1, it's just x. X over r is still 1. Okay. Now we're going to look at distances. So if we look at the distance, and let's change colors again, if you have the same central angle, the chord is going to be the same length. So this is the chord for a minus b, and this is the chord for b minus a. But the chords are going to be the same. They don't look like it, but they are. So we're going to show that that distance equals this distance. The distance from this first one is, you take the square root, if you remember all these, cosine A minus cosine B squared, that's in parentheses, plus the sine A minus sine B squared. Remember, it's the sine A minus sine B squared. This is y2 minus y1. X sub 2 minus x sub 1. This is the distance formula. You remember the distance formula? Square root of x sub 2 minus x sub 1 squared, y sub 2 minus y sub 1 squared. We're just using the cosines as our x's and y's. Now that's supposed to equal this other distance. Notice this is just distance to 1, so this is going to be a little nicer in one sense. Square root of the cosine of b minus a minus 1 squared, because that's the x, cosine of b minus a minus 1, and the sine of b minus a minus 0, so we won't worry about that, squared. So those two distances are the same. And this is how we're going to include this difference angle. So when we square this stuff, first of all, if you square both sides, you're going to get rid of the square roots, and we'll do that first. So don't worry about the square roots anymore. Square both sides. Now I got to write this a little small, because then we use our knowledge of squaring a binomial. It would be cosine squared A minus 2 cosine A cosine B plus cosine squared B plus, I'm going to put this underneath, the sine squared A minus 2 sine A cosine A, not sine A, sine A sine B, that's a sine, plus sine squared B. This is a sine. Sine, sine, sine. Does that make sense? So now this is square of the first, cosine squared b minus a. Double the product, minus 2 cosine b minus a. And then square of the second, plus 1. And then we've got the sine squared b minus a. So I couldn't fit all that in one line. But look at all these. Cosine squared a, sine squared a. That's just 1. Pythagorean identity. Cosine squared b, sine squared b. That's just 1. Cosine squared plus sine squared. We have left here minus the 2 cosine a, cosine b, minus the 2 sine a, sine b. Now here we've got cosine squared b minus a and sine squared b minus a. That's just 1. We've got the 1 here that was already there, plus another 1 for the cosine squared plus sine squared, minus 2 cosine b minus a. Okay, you got 2 on the side, cancels with 2 on the side. We can divide everybody by a negative 2. And we get cosine A, cosine B, plus sine A, sine B equals cosine B minus A. Boy, that's almost right. We only need cosine A minus B. Shucks. If we had a negative here, A minus B, we'd be okay. But we do. Because the cosine is an even function, and the cosine of a negative A equals the cosine of A. So this is the same as the cosine of A minus B. So now we have the first one. It's not the first one on our list. This is really like the third one on our list. But we've got a place to start to find all the rest. Now, just because this works for one of those situations doesn't mean it'll work for the other one. You've got to show that too. You've got to verify that that's true. You've got to derive this. So if I want the cosine of A plus B, what I know is the cosine of A minus B. How do I write this so that it's going to work for the cosine of A plus B? Well, you can write cosine of A plus B as the cosine of A minus a negative B, correct? Okay. Now, when you start using now this is then the difference. Now, be careful not getting this confused where these have to be both positive numbers. Whatever's first is first, and whatever's second is second. First in this case is A, but second is a negative B. So that's what you've got to keep in mind. So it's the cosine of the first, cosine A, cosine of the second, cosine of negative B, plus the sine of the first, sine of A, the sine of the second, the sine of a negative B, because now we're using negative B for this B. So, but hold it, the cosine of a negative B is the same as the cosine of B, because that's an even function. And the negative function identities tell us that. So cosine A, cosine B. But hold it, the sine of a negative b is a negative sine b. But I'm not going to put the negative there. I'm going to put the negative out front. Sine a, sine b. And so now we have that second form for the cosine. And we can say, now we can use cosine of a plus or minus b is the cosine of a, cosine of b. Now, if it's plus, we use minus, and if it's minus, we use plus. So, it's minus plus sine a, sine b. Those we can now use no matter what. Okay, now that we know the cosine a plus or minus b, let's work on the sine of a plus b. Let's see, the sine of a plus b is the same, let's use the cofunction identity, as the cosine of 90 degrees minus a plus b. Well, let's see. I could rewrite this and not have those gathered the way they are, but group them with a, and notice this negative would also go to the b also. So this negative a and negative b. So let's group the 90 minus a stuff. And now you've got the cosine of a difference. So it's the cosine of the first, that's 90 degrees minus a. The cosine of the second, b, with minus its plus. The sine of the first, sine of 90 degrees minus a. Cosine, I'm sorry, the sine of the second, which is b. Okay. Now, the cosine of 90 degrees minus a is the cofunction identity too. That's the sine of a. Cosine of b, and the sine of 90 degrees minus a is the cosine of a, sine of b. So, it's the sine a cosine b plus cosine a sine b. Now, that's the one we need. That's up here also. To do minus, we can look at the same thing. Let me, I guess, write that again. So what we're going to do is sort of use the same thing. So the sine of a minus b should be minus over here. Do this in a bright yellow. So the cosine of 90 degrees minus a minus b, the cosine of 90 degrees minus a, but then this would be plus b, the cosine of 90 degrees minus a, cosine of b, and for the cosine this would then be minus the sine of 90 degrees minus a and the sine of b. But now this sine a cosine b minus cosine a sine b. So we just needed to put that minus sign in there because it's the same argument all the way down. Now, what about the tangent of a plus b? Well, it's supposed to be the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. Well, let's use our ideas from before. This is the sine of a plus b over the cosine of a plus b, because that is our ratio or quotient identities. The sine of a plus b is the sine of a cosine b plus cosine a sine b over the cosine of A plus B is cosine A, cosine B minus sine A, sine B. Now what we're going to do is divide everybody by this quantity down here in the lower left. And the way you remember that is because we need a 1 there. So this is the sine of A, cosine of B, over cosine A, cosine B, minus the cosine of A, sine of B, over cosine A, cosine B, over the cosine of A, cosine of B, over cosine A, cosine B, minus, this should be a plus from up here, the sine of A, the sine of B, over cosine A, cosine B. Now, of course, I ran out of room, but let's take a look at this. The cosine B's cancel. Sine A over cosine A is tangent A. The cosine A's cancel. Sine B over cosine B is tangent B. Of course, cosine A, cosine B over cosine A, cosine B is all 1s, minus the sine A over cosine A is tangent A, times the sine B over cosine B is tangent B. And to get subtraction, we need only go through the same process with a subtraction sign. So if this is subtraction here, it's subtraction here and here. It is subtraction here, but addition here. It is subtraction here, but addition here. And now it becomes subtraction here, but addition here. So, we've gotten all of our identities, at least these sum and difference identities. And now we can go through some examples. So let's do some examples, okay? What is the exact value? This is number 12. We want the exact value of the cosine of 105 degrees. And you might say, hold it, exact values. Mr. Anderson always said that would probably be special angles. Well, it is. What two numbers add up to 105? Let's see, the special angles are 30, 45, 60, 90. Okay, so 105, well, 90 is, you need 15, so that doesn't work. 60, hold it. 60 and 45 add up to 105. So the cosine of 60 degrees plus 45 degrees. Now we did addition, but it could be subtraction too, but not in this case, I guess. So this is the cosine of the first, cosine of the second, minus the sine of the first, the sine of the second. So what is the cosine of 60? Oh, now we got to bring out that special thing again. Let's see here. The tangent equals the sine over the cosine, square root 0, 1, 2, 3, 4 over 2, square root 4, 3, 2, 1, 0 over 2 for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So 60 cosine excuse me. So let's see. The cosine of 60 is the square root of 1 over 2, or 1/2, times cosine of 45 is the square root of 2 over 2, minus the sine of 60 is the square root of 3 over 2, times the sine of 45 is the square root of 2 over 2. So this is really the square root of 2 minus the square root of 6 over that common denominator, 4. So this is another example for section 5.3 in trig. Here's the cosine of negative 7 pi over 12. We want to find the exact value for our special angles. The tangent equals the sine over the cosine. Square root of 0, 1, 2, 3, 4 over 2. This is the square root of 4, 3, 2, 1, 0 over 2. For 0 radians, pi over 6, pi over 4, pi over 3, and pi over 2. So we need some fractions that are going to add up to a negative 7/12. Don't worry about the pi, it's just the 7/12 that we need. But they need to be, sixths or fourths or something like that. And we need a negative, I guess. So you can have too many and subtract. But I think it's easier. If we have a negative 3/12, and we subtract 4/12, we get a negative 7/12. Well, 3/12 is 1/4, and 4/12 is 1/3. So we're talking about pi's, then we're thinking of pi over 4 and pi over 3, special angles. So this cosine is really a negative 3 pi over 12 minus, this is negative, minus 4 pi over 12, which is really the cosine of a negative pi over 4 minus pi over 3. So this is the cosine of a negative pi over 4, cosine pi over 3. And if that's subtraction, then we have addition. The sine of a negative pi over 4 and the sine of pi over 3. So this is going to keep this separated. The cosine of a negative is the same as the cosine of the positive because it's an even function. So cosine of pi over 4 is square root of 2 over 2. That's over here, cosine of pi over 4. Cosine of pi over 3 is 1/2. Plus, but this is the sine of a negative, so this is really going to become negative because it's an odd function. The sine of pi over 4 is square root of 2 over 2. And the sine of pi over 3 is the square root of 3 over 2. And so we get square root of 2 minus the square root of 6 over that common denominator 4. Boy, does that sound familiar. Let's do for our next one. Number 56. We're supposed to find the cosine of s plus t and the cosine of s minus t. Let's do s plus t because s minus t is really the same. Remember, this is the cosine of s, the cosine of t minus the sine of s, sine of t, and for s minus t, we'll just make that a plus in between. We're given that the cosine of s is the square root of 2 over 4, and the sine of t is negative square root of 5 over 6. So let's think about our angle S. If, well, they also say S and T are in quadrant 4. Okay, that's not quadrant 9, that's quadrant 4. Someplace over here. So the cosine is the adjacent, square root of 2, over the hypotenuse, which is 4. We can figure out what y is. Y squared plus the square root of 2 squared is equal to 4 squared. Y squared is 16 minus 2, or 14. And then y would be, do I use plus or minus? Well, it's in the 4th quadrant, so it's a minus square root of 14. The sine of t has its own little picture. Also in quadrant, man, what a horrible picture. Quadrant 4, this must be t here, this is s. Sine is negative square root of 5 over 6, so this is the negative square root of 5. Hypotenuse is 6. So this is x, but it's x squared. I need to do that here. X squared plus negative square root of 5 squared is equal to 6 squared. So x squared, let's see, subtract 5 from 36 is 31. So x is the square root of 31, is a positive or negative. 4th quadrant, positive. So, what is the cosine of s? Let's see, that's over here. Cosine is the square root of 2 over 4. Let's change colors. So, the cosine of s, square root of 2 over 4. Cosine of t is the square root of 31 over 6. Minus the sine of s, negative square root of 14 over 4. Sine of t, negative square root of 5 over 6. Now, I'll probably just ask you to do this, so I don't need you to show me at this point that you can multiply these and simplify them. This is what I'll probably ask you to do. The next thing we should probably look at is verify